Welcome to the video lecture by Dr. Biju Vasudevan for the course Calculus 3 and Math 211 for JUC students. This is the part 2 video for the week 9. And in this particular video, we are going to discuss the topic called functions of two or more variables. And you should remember one important thing, that this video is an explanatory video of the PowerPoints available on Blackboard. Here we is gonna solve some problems from this topic with all possible steps. Let's think of the definition of function of two or more variables. Definition of function. The function f of two variables x and y is a rule that assigns a unique real number f of xy to each point. For example, in our real life, we have seen a lot of occasions where there are functions of two or three variables. For example, when we find the area of any rectangle, we know that is length into breadth. So length and breadth, isn't it? When we are finding area, length and breadth both should be greater than 0. So we here restrict the values of a and b. In general, if I write f is x, y, we don't need to restrict. X and y can take any real value. So this is in general, but if I am looking for area, we know that length and breadth should be positive. So in this case, we are restricting the domain, the values that can be given for L and B. So this kind of the values, we call it domain. If there is no restriction given, we call it natural domain. So here restrictions are allowed, so the domain is the positive values of x and y here in this L and B. So this the formula of area involves two variables L and B. This is a function of two variable. Example of a function of two variable where a pair of values of L and B gives you a unique value for A. That is it here. A function. Now read the definition. A function f of two variables, you can write z is a function of x and y. Is a rule that assigns a unique real number f to each pair xy. So where these xy are from is called D. D is the xy plane where all the values of x and y are from. So we call D as a domain. As far as there is no restriction and it is true for all values of xy, we call it natural domain. The same can be expanded for another variable function of three variables. Here we can write W is a function of x, y and z. So every collection of values of x, y, z will give a unique value for W. So we can say here there will be a domain, there will be a range, and f is a function from domain to range. If you give two different values for x and y, you will get one value here, unique value. And output, we can call it f, image of this x and y, isn't it? So this is we have. So here we can give some values for x and y. If your input is 1, 2 for this function, your answer is 1 into 2. The answer is 2. If you give 2, 2, the answer is 4. So for every input on ordered pair, you get a single valued output. So this is what the definition of function of two variables. And you can extend the same for a three variable function. Now another important thing in this topic is level curve. Level curve. What is a level curve? Let z is equal to f of x is a function. Z is f of x comma y is a function in three-dimensional space. And we are cutting this the surface by a plane. Z is equal to a constant plane. Z is equal to k. Z equal to k. So here we substitute z equal to k. K is equal to f of x comma y. Now the function of x comma y will be equal to a constant k. This will give actually the intersection this is the area of intersection of the plane and the level and the surface is it. So its projection on the ground will give a curve. This is called a level curve of the z for the given z is equal to k. What is a level curve? Now we'll see. We are familiar with some topographic or contours maps in which three-dimensional landscape such as a mountain range or a trench is represented by two-dimensional contour lines or curves with a constant elevation. This kind of curves we call it level curves. That is, one more time you will see, if there is a surface z is equal to f of x y in three-dimensional space, we cut a horizontal plane z is equal to k. So this is on a three-dimensional space, isn't it? So we cut some z is equal to k with this one. The intersection is projected on the ground xy plane and the projection gives us a curve. This curve is called a level curve. So level curve can be found in an equation of z is equal to f of xy by letting z is equal to k, a constant value. And next, the projection of this and the same point that we already said, and the xy plane is called a level curve of the height. So this height, when the height changes, the curve changes. See, when you go towards the top, the curve will be very smaller. And go to the top, the edge of this mountain, you will get a small curve here. So when you have a mountain like this mountain can be expressed on a two-dimensional sheet. The heights, every level of the height. So this is the height, this is second level, this is third level, fourth level, fifth level. So when you intersect the surface here, you'll get the first curve. When you intersect the surface here, you will get the second curve. You intersect the surface here, third curve. So when you go to the top, the curve will be very small and small. So the collection of this, every curve is called a level curve, and this collection of curve is called a contour. And contour map or contour plot. The height has been expressed, the three-dimensional height has been expressed on a two-dimensional surface by using contour. By using this concept of level curves and contour curves, we can express all mountains and trenches on the atlas map. Now let us see how to find the level curves. And so there's another graph of level curve. We have been given a paraboloid shape, and we are cutting here with z is equal to k. So it's a projection of the ground is f of xy is equal to k, determined by this equation. So if you come down now when you go to the down, you coming down, then the curve will be smaller and smaller. You will get very close to this one. So the height level is represented by every curve. For every increasing curve, the increasing height, the curve is getting larger, isn't it? This is the case. This is the case of another case of level curve. And the next one is yet another figure for level curve for this mountain. For every level, k is 0, k is 1, k is 2, k is 3, k is 4, k is 5, k is 6. We cut the plane, we intersect the plane with the given level surface, and then we get this is a projection on the ground, and the right side is given the for height level 6 you get the smallest curve inside it. For height level 1 you get the curve here. For height level 0 you get the outermost curve. So this is the projection of this intersection on the ground. So in the map you can see this one to represent the heights of the mountain. And now yet another graph can go through it. This is given as z is equal to 4x square plus y square. How to find the level curve? An example has been given here. So we take z is equal to k is a horizontal plane. We are cutting it with this given surface. Z is equal to 4x square plus y square. When k is 1, what happens? We get 1 z is equal to k, so 4x square plus y square is equal to k. When k is 1, when k is 0, you get a point. 4x square plus y square is 0, so it should be a point. 4x square when k is 0. When k is 1, you get 1 is equal to 4x square plus y square, which is an ellipse. You can write this one as which is an equation of ellipse. When you write this one as 1 is equal to x square over 1 by 4 plus y square over 1, isn't it? So it's a is 1 over, so a square is 1 over 4, a is plus or minus root of 1 over 2, isn't it? So it will be a distance is 1 over 2, but y distance is 1. So this is an ellipse where y intercepts are 1, b square is 1, b is plus or minus 1, isn't it? And x intercepts are plus or minus half. So this is an ellipse. This way you can find. So for every k value, you can find an ellipse representing the level curve of the height levels of this paraboloid. Fine, let's go to the exercise set problems 13.1. Now we are first discussing the value of the function of the given xy value. Okay, exercise set 13.1, problem number 3. What's the given problem? F of xy is equal to xy plus 3. So what is the question? Question number A is f of x plus y comma x minus y. So x should be replaced by x plus y. This x will be replaced by x plus y. This y will be replaced by x minus y. That is it. So simplify this one, you get x square minus y square plus 3. And for B, problem number B, what happens? X will be replaced by f of xy and 3x square y cube. X will be replaced by xy. So what is it? Instead of xy into y, 3x square y cube plus 3. Now simplify this one. 3x cube y raised to 4 plus 3. That is it. For problem number 3. Just substitute the case of A. Wherever x comes, replace it by x plus y. Wherever y comes, replace it by x minus y. That is the case for A. And B, wherever x comes, replace it with xy. Wherever y comes, replace it by 3x square y cube. That's it. And let's try problem number 7 now. What's happening in problem number 7? We are given f of xy is equal to x plus 3x square y square, isn't it? Whatever the value of x will be used here and here. The values of y will be used here and y square, isn't it? That's it. So first thing, another information has been given here, x of t and y of t. What is x of t? X of t is t square, y of t is t cube. I will show you one problem and the rest you can practice. F of x of t, isn't it? F of x of t. What is f of x of t? X of t comma y of t, which is f of x of t is t square, y of t is t cube. Now wherever x is there in the equation number 1, replace it by t square. So x is t square plus 3 times t square whole square, and y is t cube whole square. So simplify it, you get t square plus 3 t raised to 4 and t raised to 6. You can write t square plus 3 t raised to 10. That's the answer for it. That's the answer for the problem number A. And in this similar way, you can find what is x of 0 from for B. You first find x of 0. Substitute t is 0. X of 0 is 0 square, so it is 0. Y of 0, which is 0 cube, is 0 0. So what is f of 0 comma 0? X is B. X of 0 is 0. Y of 0 is 0, isn't it? 0 and 0 plus 0. The answer is 0. See, you try your own. And let's go to the next problem. A function of 3 variables has been given now. The same task should be done. I would like to solve one of them. Is it good to solve both? Okay, no problem. Question number A. See, x should be replaced by x plus y should be replaced by x minus y, and z should be replaced by x cube in the given formula. So we are given x, y, z is equal to z x y plus x. So we will write f of x plus y, x minus y, x cube as, see, z will be replaced by x cube, so this is x cube. X will be replaced by x plus y, and y to be replaced by x minus y plus x. So simplify, or you can simplify further if you want. Expand and simplify this one. That's it. I'm going for B. In the case of B, we want f of xy. X will be replaced by xy. Y will be replaced by y over x, and z will be replaced by x z. That is it. And now let's do it. In this, z will be replaced by x z, and x will be replaced by xy. Y will be replaced by y over x plus x. Here in this case, the case x is to be replaced by x plus y, so this the last term is x plus y. So here it is x plus y. So first term, now x is xy. When you simplify this one, you will find z y square x plus xy. Then you simplify this part A, you will get x to the power 5 minus x cube y square plus x plus y. Simplify, that's it. And now we will go to the next problem. In this problem, sketch the domain of the function f. Use solid lines, that is to be underlined. Use solid lines for the portions of the boundary included in the domain. Solid lines and dashed lines for the portion not included, that is to be underlined. Okay, now let us see problem number 19, 21, 20, 22. There are 4 problems. You can solve it very easily. See, ln function x has been defined for all x greater than 0. You should remember these 4 rules. And square root of any function has been defined for all values of g of x which is greater than or equal to 0. Because otherwise, if g of x is negative, the function, if this is negative, the term inside the square root is negative, you will get complex numbers. Here x is defined, ln x is defined, so this to be remembered while solving this 4 problems, right? Now let's solve 19. ln, as we have been given ln 1 minus, so 1 minus x square minus y square should be strictly greater than 0. This gives us that, this gives information that you take x square 1 is greater than x square plus y square. This is the answer, this is the domain. So when you give values of x and y to this problem number 19, all x and y should satisfy this condition. It means, see, remember one thing, when you write x square plus y square is equal to 1, it is a circle. You are on the circle whose radius is 1 and center is 0. You are on the circle. All the points on the circle will be denoted by this equation. But when we write x square plus y square is less than 1, we are talking about the interior of the circular disc whose radius is 1. When I write x square plus y square is greater than 1, you are talking about the exterior of the circle. So in this case, our answer is interior of the circle. Interior of the circle whose radius is 1. Radius is 1 and center is origin. This is a circle, x square plus 4. We have no equality here. So finally we have to draw the graph. See, you sketch the domain. That's the question. We are going to sketch the domain, okay, for problem number 19. Here I am writing this one. This is actually a rough idea, ignore it. Use dotted line because there is no equality, so the circle on the line there is no xy could be used here. And then x square plus y square less than 1 says all the points inside the circle whose radius is 1. So all the points inside the circle but not on the boundary. If there is equality here, you can use the boundary line in dark line, that is solid lines. Now I am using dashed lines because the boundary is not involved. This is the graph for case problem number 19. Now I am talking about problem number 20. What is happening here? Under square root, so under square root it should be greater than or equal to 0, and whatever under square root to get a real roots, isn't it? You have to write x square plus y square minus 4 should be greater than or equal to 0. Now you see you are getting an exterior of the circle greater than 4. You are above the radius level. So this is 2 square, radius is 2 square, you can write 4. So radius is 2. This is 2. This is a circle with the center, origin and radius 2. So when we draw such a circle with the radius 2, roughly this is 2, negative 2, 2, negative 2. I use dark line because equality is available here, isn't it? There is equality, so we use dark line. In the previous problem there was not dark line, it was a dashed line, dotted line, isn't it? So now the question is whether interior or exterior. We are the x square y square is greater than the radius, so outside. If it is lesser than the radius, then you will find interior. So all the area outside the circle, including on the circle, is our domain. This is problem number 20. You can try. Okay, I will solve these two problems for you. Okay, now problem number 21. This function is defined for all values of x for y square not equal to x. When y square is equal to x, the denominator is 0, you get function infinity, isn't it? So this function f of xy has been defined for all values of x and y except this condition. So this is x is equal to y square, a parabola towards the right, but not include the elements on the parabola. The x y values on the parabola are not included, so it should be a dotted parabola, and all other elements on the surface except the points on the parabola. So we don't want y square is equal to x. So on this parabola the value of x is equal to y square, so we don't want the elements on the parabola, we want all other elements on the xy plane. So this is the graph for this problem number 21, and obviously 22, if you try in the xy plane. 22, what is 22? ln xy, ln xy has been defined for all xy, the product should be positive, therefore either x greater than 0 and y greater than 0, or the second condition x negative and y is negative, no equality. So the these lines, the axis are dotted lines, we cannot include the x and y axis, but we can use the zone positive quadrant where x and both y and x and y are positive. So this gives the positive first quadrant, and x and y both are negative in the third quadrant. This here x is negative, y is negative, so the xy plane in the first and third quadrant excluding the coordinate axis x and y will be the domain for the problem number 22. Here x and y no equality allowed, so we don't want the line x equal to 0 and y equal to 0. Ignore it. That is it. So all the graphs are there in the PowerPoint, you can verify. The final topic is, final problem is 23. Describe the domain of f inverse. See, this is problem number 23. This is the last problem of this chapter for you guys. We have to explain, or even write in words. Do not sketch the graph, don't need to sketch. Even you can try to sketch if you have an idea. Describe the domain. See, problem number A, isn't it? Here f of xy is defined as x into exponential under square root y plus 2. See, x can take any value. X belongs to real numbers, any value from real number, but y plus 2 is under square root. So under square root y plus 2 should be greater than or equal to 0. Can be 0, even under square root can be 0. So since y plus 2 is under square root, we should get y plus 2 greater than 0. It means that y is greater than or equal to negative 2. It means, what is it in the graph? X can be any value from negative infinity to positive infinity. This is x-axis. But y, this is negative 1, this is negative 2. Negative 2. So there should be a line, dark line, because there is an equality, and all values above this line. So how can you write in words? Describe the domain. So this is the domain. All x value from negative to positive infinity, and all y values greater than or equal to negative 2. So you can write all the points on the xy plane above and on y is equal to negative 2. So that is it, and on, because equality is allowed, therefore y is equal to negative 2 can be considered. This for problem number A. Will you try problem number B just like the previous one? Because under square root, the under square the function under square root should be greater than or equal to 0. Just take it, it will be a sphere. You can try. In the case of C, there is nothing to worry. There is no square root, there is nothing, there is no ln, and there is no rational function. So you can simply write for all values of x, y, z in 3 space. So it's 3 dimensional x, y, z can take any value. So here in the second case you can try what is happening in the second case. It should be greater than 25 minus x square minus y square minus z square should be greater than or equal to 0. So it will be interior of the sphere including equality. So interior on the sphere. So you can try the second part yourself, writing the words for it. That's it, the second part of the video. Thank you very much. We will meet again for the topics of week 10, maybe uploaded by the end of next week. Thank you very much, students. You have any doubts and queries, you can send through Blackboard or mail. Okay, or you can send me videos, of course. Thank you very much.